Oh, yeah. All right. Olaf, hello. Welcome to the show.
Good morning, Tim. Pleasure to be here.
Oh, thank you very much for coming out. For people who are watching this show, I've just been mind blown, flipping out by some of the amazing 3D printed stuff that Olaf has brought in to talk about today. It's insane. We'll get to some of that soon. Olaf, the field you work in is so interesting. It's cutting edge technology. What led you into additive manufacturing and 3D printing?
Well, really, my background was in product development. So developing all sorts of products for companies, medical products. I did a lot of work in lighting, so doing lighting discs and dimming systems. And part of that was developing better products faster. And at the time, in the mid-90s, it was prototyping. And we used 3D printing. Back then, it was called rapid prototyping for testing our ideas to make sure they weren't crazy.
Yeah.
And to save money. And then it's been getting better and better and better over the years, and it's turned into real manufacturing. And that's what got me really excited about it. It changes the way we manufacture, changes the way we design, because you can now have an idea, an hour later I can put it in your hand and you either pack up laughing because it's a dumb idea or not. But that's how you know your idea is good or bad, is by actually realizing it.
It's amazing. It gives you. It seems to have gone in two ways. Now it's developing into the commercial manufacturing with massive machines and being able to build things like boats that I've seen being 3D printed, but also consumer-led, little 3D printers at home to be able to manufacture, which is great.
And for $600, you can get a top quality machine that produces. If you're doing sort of World of Warcraft or gaming, and you can print all your characters, that is an amazing benefit.
Yeah. Or just being able to replace things. I've got a welder in the shed and I've lost a little piece that's broken, which feeds the wire through the MIG welder. It's the perfect opportunity to go and get the dimensions, what that is, and just 3D print another one.
My wife's vacuum cleaner had a broken clip. So I just catted it up, printed it out, replaced it. I posted it on LinkedIn. And in like 2 days, it got 120,000 hits. It's probably the most hits I've ever had on a story. And it's just fixing a vacuum cleaner.
Well, that's relatable. Everyone's got a vacuum cleaner that's broken. I've got one out here. It's doing my head in. The thing just keeps breaking. That's pretty amazing. But that shows the interest, doesn't it? 120,000 in 3D printing.
Yeah. And it's both on the consumer side, these being able to fix things, make things where you need them, when you need them, and on the industrial side for making better products that are lighter, that are customized to you, the user, and so on. So it's huge.
Yeah, I've got a really good friend, Shannon from Pro CNC. I was toying with asking him to come down and join us on the show because he's a fabricator and he does some 3D printing. He showed me some things that he was 3D, I believe he was actually cutting these out of dies of hard plastic, which was for an industry in New Zealand. I won't tell exactly what it was because he couldn't tell me exactly what it was. But the complexity of the shape and the organic looking nature of these shapes. Let's just say it looked like a heart. It wasn't a heart, but kind of what it looked like. Just mind-blowing that you can produce something like that.
And that's the big benefit of 3D printing. So my advice to people is if it's something you can CNC machine, which is what your mate does, then probably CNC it because it's not worth printing.
Yeah.
Whereas if it's complex, if it's geometrically complex, that's when it really starts to smile. So you'll notice all the 3D printing products are not simple products.
Yeah.
For that reason.
Yeah. Things like, we'll have a look at these in a moment, like your guitars, elements where there are lots of voids and spaces in them. Is that the area for 3D printing or is that the tough challenge for 3D printing?
Well, so guitars is a good example. It's something I do as a hobby. If I was going to make a standard Fender Telecaster or Strat, a solid-bodied guitar, much better ways of making them than 3D printing. Yeah. I could bandsaw it by hand, I could CNC machine it. But all of mine, I call them theme guitars. So inside the body of the guitar, you've got New York cityscape inside the guitar and so on. And it's because otherwise it wouldn't be worth printing them. So I sort of play with the complexity you can get from 3D printing.
Oh, yeah. Isn't it? With the 3D printing, with things like text to image, text to video, those type of things, it's almost as though we're able to now manifest our dreams. Like if you can visualize it, you can probably now make it, or very close.
It's getting close. Already, all the AI sort of engines, ChatGPT for text to images, they're starting to get text to 3D images. It's still early days, but another year or two or three, It's going to change the way, people will be able to type into the computer whatever it is they imagine, and it'll spit out a ready-to-print design for them.
That's amazing.
It's incredible. It's a bit scary as well, but yeah.
It is, because that's just so, that's such a powerful enabler.
Absolutely, yeah. And I mean, we use it now for inspiration. You know, you can go into Mid-Journey and type in what you want, and it'll generate 12 different pictures of the concept. And then from there, you can turn them into real products. You do have to be a bit careful, because a lot of these AI things don't always get it right.
Yes, you get extra fingers and things out the side.
And this is what worries me a bit, is that people start using ChatGPT, whatever it is, to replace knowledge.
Yes.
I tested ChatGPT last week and said, what's the difference between, it was 2 different 3D printing processes. It got one of them completely wrong. But it sounded so plausible. The way it wrote it sounded right. So if you don't know any better,
it could be dangerous.
It could be dangerous.
I've got a friend who's like that. I've mentioned it before. He's so convincing when he delivers something to you. You go, 100% I believe that. And then you'll go and research it later and you're like, hang on, that's not right. Your ChatGPT is amazing. Like I use it at my work already when I need to write out a particular paragraph, usually in the area of sales and promotional, that kind of thing. But if I need to write something out like that, I'll ask it to draft it for me, and then I take the extra 20% and use that human element of skill and experience and really polish it up. But you're right. I think if you're doing AI to 3D, that's what you do. Let it do the bulk of the hard, heavy lifting.
And then you do the refining and getting it, make sure it's right. Making sure it fits the user, fits your hand or whatever it is you're designing.
Yeah. Talking about fits your hand, what's that there?
This is, something we've been doing. We've been doing a lot of sort of software automation. So this is a cast, a splint, and it's based off a scan of my hand. So we've developed the software where you can scan a person's arm and say, I want to trim it here and here. And in 30 seconds, it'll spit you out a cast that fits you perfectly.
Wow.
It's lightweight, it's breathable.
Yeah.
You can throw it in the dishwasher to clean it when it gets smelly. And the biggest advantage is you can scratch yourself when you've got an itch.
Yes, of course.
These sort of ways of doing custom casts or prosthetics, really nice way. And of course, this one's just sort of a weird lattice structure on the outside. But you could have an app where you could say, I want a Hello Kitty on it or butterflies, and customize it to make it look the way you want.
Or it's got to be 5 minutes away from saying, I want to drop in effectively my phone into that cast. Yep. So, I would normally wear a watch. Well, I've broken my arm, but I can still have the time displayed. I can still have digital functionality. Insane.
That's actually a nice idea, that being able to put in the compartments where you can put in your storage or watches. Yeah, really nice.
Well, that was one of the questions I had for you then, was kind of jumping ahead, but was around how far away are we from printing in multiple materials in the one design at the one time. So, for example, if you wanted to produce a robotic arm where you needed to have effectively mechanical tendons, cables for data, and carrying copper cables, are we on the cusp of being able to do that type of thing?
So we are. So already you can do multiple plastics. So you can do parts that are made out of rubber and hard plastic all in a single print.
Wow.
It's the same technology we use for all the color prints that I bought today, where you've got like your home inkjet printer with cyan, magenta, yellow, black. It prints in 3D that way. You can also print electronics, so you can print tracks for doing all the coppers and the wiring. What you can't do yet is the more complex components, say the transistors, the capacitors. On their own, they have been done, but to print your iPhone all ready to go, we're still a few years away from that, but it is coming. I mean, that multiple material is, it's really the verge of the exciting side of things.
That's amazing. When that 3D printing unit comes out and becomes commercialized, that has got to be called the dream box, because you can just make anything you want.
Absolutely. And it's not only that. If you look at, all the products around us now are designed around sort of boring rectangular circuit boards. Your phone is rectangular, not because it's the best shape for a phone to be, but because you've got a circuit board, a fiberglass.
Two-dimensional circuit boards, you need to fit them in.
So imagine having your phone wrapped around your wrist, for example. Now, I'm not saying it's the best shape for a phone to be, but wouldn't it be nice if you could?
That would be a huge seller. The ability to make things look organic with 3D printing is amazing. I saw a video, this was a few years ago, I think it may have been Ford, when they were working on the Raptor vehicle. They sent a chassis out into the desert with 4 sensors and all over the thing, captured all this data from it driving around, came back, gave it to AI and said, produce us a better chassis. And the chassis it spat out was organic. It was like bird bones with massive spaces between the struts and all this, and all curved and just amazing. So,
I mean, that's an example of something similar to that. It's a brake caliper for mountain bike. But again, so you put in the forces and say, these are the forces that are going to be acting on it, and it spits you out that organic shape, weighs 45% less than the machine brake caliper.
Yeah.
So you think for performance cyclists, that's winning and losing a race.
Oh,
So,
yeah. Well, even I imagine like just bike frames, they're all tubes, made out of tubes, because tubes are the available material. It's easy to use. But if you're able to print them so that you have far less material in there, those bikes are going to be like the weight of a feather in a few years' time.
Absolutely. And again, because of that complexity you can get, that's why 3D printing gives you that big advantage of making things 60, 70, 80, 90% lighter. And that's, imagine that on a plane or on a bus. That's a huge difference.
Oh, yeah. Yeah. So what size objects are being commercially or industrially perhaps printed at this stage?
So right now, the most common sort of, let's say, metal 3D printers are, call it basketball size, about 250 millimeters cubed. There are bigger ones that'll do double the size. And then if you look at the large area, things like printing houses out of concrete, for example.
Oh, yes,
those are, on robot arms, effectively. You can print much larger than that. But right now, it's round about that basketball size is the commercially standard printers.
For metal printing.
Metal and even plastic. Problem is, the bigger you go, the more exponentially expensive it becomes. So if you double the size of something, the cost goes up 8 times.
That's in terms of the rig to support the printing apparatus?
It's actually more, it's the volume. The volume of material in your part is what determines a large part of the cost.
Yeah, okay.
So if you double the size of something, the volume goes up 8 times, so it gets
expensive
very quickly. So small things can be ridiculously cheap to print.
Yeah.
But as your size goes up, you start to have mild heart attacks when somebody tells you the price of what it's going to cost. Yeah.
I can imagine. As I said before, I've seen a picture of a boat being 3D printed, and that amazed me because that's such a complex functional object. I guess in some respects it's not that complex. It was the hull and and the fairing at the top, so not overly complex. But still, just amazing to think that, I don't know how long that might take. Maybe it takes a couple of days to print one of those out. You just start pumping them out every couple of days.
You have them on a conveyor belt. They come out. They're doing the same. They're printing cars. Same thing.
Get out.
And a car, instead of having 50,000 components, now suddenly has 2,000 components.
Yeah.
So you think about the assembly, the reliability, everything gets better with that.
Yeah. And you've got the ability, like you were saying before, to fit the form of things better. You could 3D print your battery into the door of the car, so or to a point of the car where the center of gravity is lower because the battery's down lower or something like that. It just opens up your opportunities to design.
I mean, even just on the aesthetic customization. I mean, Mini Cooper at one stage they released, you could do custom panels for inside your car with your name or flowers on them or what have you. And I think Ford, for one of their new trucks, made all the interior CAD files open source.
Oh, did they?
So customers could go and download the files, modify them, and then print their own replacement widgets for inside the car, which is quite cool.
That's great. Yeah. They're really allowing you to personalize things.
Yeah.
Oh, that's such a big, that will go off. I see there's already websites out there for 3D printers where people, it's like a recipe site. I see people uploading, here is the instructions for certain software to then print.
Yeah, even CAD files, like, websites like Thingiverse and GrabCAD, where you can download models of just about anything ready to print. So these open source communities are really changing the way you design. So if you're looking for a part for your vacuum cleaner, you can imagine in the future, you'll just go to one of these websites and say, this is whatever brand, whatever part number I need, and it spits you out the part ready to print.
And then I imagine a few years after that, you'll have one of these things in your home, which will take place somewhere in the home. I feel like it'll become an item like the television or the refrigerator. It will be such a useful household item that it will find the place, which is going to be in the den or the lounge room. So, where's your big 3D printer? Oh, it's in the den, or
Look, it's a tough one. I mean, people like myself, geeks, have got them at home already.
Yeah.
We've got them already. To me, I mean, I think about it a bit like the sewing machine. A lot of us are wearing, we've got sewing machines at home, but we're not all wearing homemade clothes.
True.
I think the printer will be in that area. It'll be similar to a sewing machine where it's brought out when you need it. Because you've got to design the part. Now, as you start having these bigger libraries,
That's
it becomes
the thing.
easier.
Yeah. Because I imagine, let's say use Dyson vacuum cleaner as an example. A part breaks on that. I imagine that you would be able to just go and, with an app, scan your Dyson, scan the part, and it would then send to your printer, and all of a sudden you've got that part, ding, 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 ding,
Absolutely.
coming out.
And I think the barrier there is not the technology. The technology can do it already. It's the manufacturers saying, let's open source our designs and not... what's the point of keeping the shape of a knob top secret?
Well, here's the other thing. If your vacuum cleaner breaks, like ours has now, I'm in the situation where if I could print and replace that part right now, simply and easily, I would do it. But if they don't allow me to do that, there's a real good chance I'll go back to the store and buy a different vacuum cleaner.
Yep, absolutely. And you think about, we're talking about extending the life cycle of things. We're talking about sustainability. Everybody's talking about it. So what's the point of you throwing away a vacuum cleaner that's missing a knob rather than fixing it and getting it running for another 3 years?
And that happens all of the time. As I mentioned before, a big shout out to the Helensville Community Recycling Centre. There's been amazing people down there, amazing management. But there are so many pieces of houseware that turn up down there, which are with a tiny part broken off them, and suddenly they go from being seen as a usable item to either they may no longer be usable, but they need a tiny amount of effort to fix, or they're still usable, they just don't look quite right. Being able to just tweak those things, far more sustainable way of looking at the things you buy.
Absolutely. I mean, my house is full of repaired things. We brought some lights. I was living in Sweden for 5 years. We brought back some lights with us, and I forgot the widgets that allow you to screw it to the ceiling. So I printed them out, put them up. It took an hour, and it was done. And again, it changes the way you use your product or extend the life of your products.
What sort of materials are available for 3D printing today?
So right now we've got about a dozen different plastics we can print from. They're quite common, and I'm talking industrial production rather than hobby level stuff. Metals, we can print in aluminium, titanium, gold, silver, stainless steel, tool steel. So a whole bunch of different metals that are available for printing today.
And what limits the metals that are available?
Effectively, it has to be a weldable metal. So the metal printing works on powder, and a laser draws on the powder and welds it together. So if your metal's if you can weld with it, you can print with it.
And if you can't weld with it, can you
There
do
are
something?
ways around it. There's another technology called binder jetting, where you have your powdered metal and you print a glue onto it to bind it together, and then you can do stuff afterwards. You can press it under great pressure or sinter it, melt it together to get solid metal out of it.
Right.
So there are ways around it. But most commonly today, titanium, because it's a hot metal for aerospace and medical. Stainless steel, of course. Aluminium, because it's lightweight. So that this brake caliper, that's printed in aluminium.
Is it?
Yeah.
Wow. And that guitar, we've got to talk about that guitar.
Yeah.
So this guitar is the body is made out of wood.
Yeah, and that's what makes this technology different. It's that same technology I was talking about. It's called binder jetting. So it's sawdust, so waste from the wood industry. You spread a layer of sawdust, and then you inkjet print bioepoxy. So epoxy resin made from lignin, from, again, waste wood product. You print on it where you need to bind the wood together.
Amazing.
And because you can have different inkjet printers with different colors, you can actually get the wood grain back into it.
So that's what you've done there. That's how you've got that wood grain color back into it.
That's why you've got the brown and the darker brown to get the wood grain in there.
I mean, that guitar is an astounding guitar because of the technology that's been used to create it. But that's just a fucking beautiful guitar. That's an awesome guitar, man.
I like to think of them as playable works of art. Sort of thing. And again, this would be impossible to machine or do any other way. Whereas if it was just a straight, solid body, there'd be better ways of making it.
Yeah.
But to me, what excites me about this technology is it's, all this, the lignin and the sawdust would at very best get turned into MDF, but typically it's burnt, it's incinerated.
So these are reusable, sustainable products that you can start to print amazing things out of.
Now, whether a guitar is sustainable or not is probably debatable, but if you play guitar, you can never have too many of them.
Well, it's art. I think it gets a pass because it's art anyhow. But that's amazing. That piece there. Do you know how long it took to print the body, just out of interest?
The print job probably would have been about 8 or 9 hours to print the body.
Wow. And then once the printing of something like that has happened, do you know how much touch-up and polishing work is needed to...
All up, it took me probably about a day of I clear coat them to protect them from UV, from sunlight. To clean everything up, it took me probably about a day, and then assembling them, wiring them all up, setting the action on them to be nice and playable. Probably another day of that to get it all right.
That's viable business if you can pump a guitar out a day.
Yeah, I mean, I'm building number 102 now. So I've been doing them for about 12 years now. So I've sold about 85 of them, and I got one of each in my collection, or one of each design. So it's it's a nice hobby business.
Oh, it's amazing! It's amazing business because I can just see how you've got the ability now to say to people, hey, what's the guitar you would like? Okay, you tell me, we'll make it customized for you, and it'll be there in 2 days because it's only going to take me a day to make for you.
Absolutely.
Instead of 6 months.
And not only that, I mean, if because it's digital, you can see the center of gravity. So they say, I want a guitar that's more like a Gibson SG that had a really heavy neck, and you can move material around to give it the center of gravity, the playability. If they want to cut away here for their arm, you can fully customize it. So all the guitars I make for customers, at the very least, I put the band name or something on the printed into it.
Yeah.
I've offered to scan their heads and make like the knobs as their heads and that sort of stuff. But
That's great. That's a steampunk one.
Steampunk one. What makes this one different is everything moves.
Moving parts. Get out of here.
And to really hurt your brain, the whole body all printed in one piece. So it's not assembled afterwards. It's printed as one working assembly straight off the machine. So you blow the powder out from between the gears, and it's ready to go.
That's mind-blowing. That's insane.
Makes it a little bit different.
That's incredible technology. I didn't realize. I mean, I'm interested in this topic. I thought I kept a pulse on things. I had no idea you could print moving parts like that.
It's the same. I mean, this bit of sort of chain mail. I mean, that is printed, assembled in one piece, ready to go. So you can imagine, companies like Weta for Lord of the Rings doing all the armor and the chain mail. This is an absolute pleasure and a lot lighter to wear than if it was made out of steel rings linked together. And that is printed as you see it there, fully assembled.
It's a chainmail scarf.
Yep, to be fashionable.
Check this out. Oh, shizies. That's amazing. Really, really amazing stuff. What are the two coloured pieces that you have there?
So I've got a few coloured pieces. So this one here is a conch shell. So it's the university's kairatiki. So they had a trumpet conch shell, a putatara it's a family heirloom. Mm-hmm. And it was getting damaged and old, and he doesn't want kids playing with it because they're going to break it.
Yeah.
So we took it to the hospital. They did a CT scan of it, which generated the 3D model of it. So we printed them out a replacement conch shell.
For public use, for kids.
Yeah, and it plays.
It works.
And side by side, you wouldn't really hear the difference between the original one and the printed one.
Astounding.
So and with the full color 3D printing, this is always a fun one. I'll take off my glasses and see if I can try to look serious. But
look at that. A 3D printed face.
So it's a print of my face. So we got the color printer, and we first did a print of my face in one piece with the eyes all, and that opened a Samsung and a OnePlus facial recognition. But it didn't do the iPhone.
Wow.
So on this one, we separated out the eyes, and the eyes move. Because we figured for the iPhone, you needed the eye movement.
They're looking for eye movement as well.
As it happens, this one still doesn't open an iPhone because those are not my eyes. I just Photoshopped the irises in. So the next thing we've got to do is take a picture of my eyes with no reflections and map that in to see if we can get it to open.
Can I have a look at that piece?
Absolutely. And that's printed again in full color as you see it there. Wow. So very much the same technology as your home inkjet printer that prints in color, but layer upon layer upon layer to get the 3D nature of it working.
That is such a good likeness.
Yeah, I mean it's frightening.
It's fool's phones.
Yeah, absolutely. And you think about that from a cybersecurity point of view. That's actually starting to open some interesting and slightly frightening areas.
Yeah, well, I mean, it wouldn't be too tough to figure a way to get a scan of someone's eyes get some app on their phone, they unlock their phone, you scan their eye. Okay, now we can print the eyes, and so it'll get past the iPhone.
It's only a matter of time. So I mean, we do a lot of fun stuff in the lab playing with things like that.
We're reaching a point in time where technology is overtaking us, and I mean that in terms of things like deep fake videos, where you'll see. You imagine coming up to an election campaign, there'll be some video will come out, and you'll be like, "Did they really say that?" I don't know.
It's already happening today. I mean, unquestionably, it's happening. every day.
Yeah.
This just puts another dimension on it.
Yeah.
Now it's no longer just digital. You can now do the deep fake
in the real
in the real world. Yeah.
Something like that. Could you print that into a softer plastic so that someone could wear it like a mask?
Yeah. So our printer only prints in rigid plastic, but another company's printer prints in soft, flexible materials, and they've just started doing soft, flexible colors. So where it's used now, so we do a lot of medical models for doctors to plan their surgery. With this new technology that prints in soft materials, you could print call it a real digital physical, I don't know what you'd call it, where the doctor can physically cut into it and test their surgery on a virtual before they do it on you. So that's where it becomes a game changer. But yeah, I think you're thinking more about the face-off type thing, where you print a soft rubber face or a Mission Impossible and pull it off. Yeah.
Well, I'm just thinking, wouldn't that be just an interesting test to print a soft version of your face and have someone else put it on their face and then unlock your phone?
Yeah, and I'm pretty sure, it's, as I said, the technology is recent but now exists. Within the next year or two, that will be doable. So we take a scan of your face so the mask fits you perfectly, slap it on minimum thickness, and a real deep fake,
That's amazing. Do you, don't go into detail, but do you get approached from people in industries asking about things like this, like face scanning or?
So we do a lot of it more on the medical side. Not so much. Nobody's approached us with the intention of fooling a security system or something. We just did it for fun because we had the color printing. We said, I wonder if you could do that. But as I said, for doing medical models, even something as simple like an aorta with a stent on it, so the doctor can explain to the patient what's going to be happening to them when they get operated on. Because pictures are okay, talking is really hard to understand. You show them what's going to be happening, they understand it a lot easier.
That's right. Or that's right. Or showing someone the specific nature of whatever their ailment may be and how it's manifest. So you can go, this is why it's happening. It's like this. See this bulge on your spine? That's what's causing this pain. Oh, wow, I can see that's my back. Yeah, we took a scan and we printed it out.
And this is how I'm going to go into it, and they can show them the path. There's at least 5 or 6 companies I know of that are doing shoe inserts, like insoles, that'll fit your feet perfectly. And not only that, on some of them you can relieve the pressure. So if you got sores on your feet, you can actually relieve the pressure in those areas.
Oh, yeah, of course. I imagine, even like the wrist guard that you showed before for burn victims and things like that, where they need some sort of support of skin that's healing but want to get air to it and be able to elevate it off beds and what have you, that kind of thing.
A few years ago, we actually looked at a project of effectively printing a scab on a burn victim, because from what I understand is from the time they get out of the fire to the time they get to the hospital, that's when a lot of the damage happens. So the idea was in the ambulance to print a scab onto so you can scan the area so you know what the area is burnt is, and you can have a printer that follows the contour and prints a scab to effectively protect them, stop the degeneration of the flesh.
This is getting like, what was it in The Empire Strikes Back, where Luke has been, I don't know, he's been inside the Tauntaun or whatever. He's been hurt somehow and he's in this like fluid, but he's got some robot sort of with little probes all over him, slowly repairing him and fixing him. That type of thing. Printing skin and...
bioprinting is already... that's probably one of the hot topics in 3D printing is bioprinting. So printing from your own cells, tissue. Yeah, effectively. So we're not yet at the stage where you can print a replacement liver or heart or kidney. But within my lifetime, they will be able to. So right now they're doing heart valves, bladders, tracheas, that sort of stuff. Effectively, think of them as bags of skin or tubes of skin, more or less. They've printed liver cells, not as a liver, but liver cells in a petri dish they can use for testing. What they haven't cracked yet is a vascular system, being able to print so you can get all the fluid, the plasma, the blood going through it. Once they crack that, I think very quickly you'll be able to print more complex organs.
Yeah.
Think about being able to do pancreas, cure diabetes overnight.
Wow.
And because it's printed from your own cells,
it's not rejected by your body.
Yeah.
That's amazing.
A lot of sort of weird ethical questions about that. Is it for just the rich? Is it for everybody? Or, right now our lifespan's 75-ish years. What should it be? Should it be 100? Should it be 150? If you can start printing replacement
that
parts?
opens those questions up, doesn't it?
Seriously does. Yeah.
You're right. So many people could detect. Okay, look, I'm pretty. Family history, heart attacks. What's probably going to get you. let's replace your heart at age 85. You know, get in early, give you a new one, rebuild. It's going to be perfect.
Yeah, replace it with a better heart.
Yeah, a better heart. Effectively, an 18-year-old heart or something.
Yeah.
You know, effectively.
Just think about the Olympics we'd have.
Well, yeah.
These augmented athletes, with better organs.
Yeah.
So.
Or just, eyes. If you could say, oh, well, okay, you've had a degenerative loss of sight because of age, we'll bring you some new eyes.
Yeah.
That's amazing.
And look, it will happen. It's not in the near future, but in the next 20 years, I would say it will happen.
If we go back to where we were talking before about AI, I wonder if those sort of things might happen very rapidly, faster than we expect, because we can now leapfrog some of the design and development by asking AI to do some of that for us.
Absolutely. And it's only a few little hurdles that are in the way. Once we cross that hurdle, suddenly you get acceleration. In a year or two, you get something real coming to the market.
Yeah.
It's exciting. It's frightening, and it's exciting at the same time.
Are you seeing industries pop up around starting to do these things now, like trying to get, like for example, like your wrist guard?
Yep.
Are the companies that are doing those sort of things?
There's now several companies that do these commercially.
Yeah.
And we're now starting to look at it as well for pets. Doing casts and splints for pets, for example.
Oh yes.
So it's a growing area. This customization, because our bodies are all different. Yeah. Again, it's a perfect area for 3D printing, because making 1,000 the same, probably 3D printing is not the best way of doing it. You're better off injection molding them or machining them. But to make 1,000 where everyone is custom made for the user, that's where 3D printing really smiles.
Customized user designed items. Yeah, definitely. Are there, I was thinking about this before, and this does seem like a fundamental challenge, scale with 3D printing. Are there ideas on how you might achieve scale?
It's already happening now. So the system we've got, the metal system we've got at the university now, for example, has only got a single laser melting the powder. Now 4 lasers are common. There's a company.
So you print 4
lasers.
items at the one time.
Yeah, or one item 4 times as quickly.
Fast.
They've now got 12 laser systems. One of the companies that does this technology, they're actually doing 1 million lasers. So it's like an inkjet printed. But instead of squirting out ink, it's got little laser diodes that switch on and off. So as it scans across the bed of powder, it's like your inkjet printer, and it solidifies the powder, almost instantly.
Wow.
So it's all about, that's where a lot of the effort is now, is making these technologies faster and faster and faster, because that then increases what you can use them for and the cost of using them.
I see aerospace, there's quite a bit of 3D printing that goes on there, and this leads on to this unit here. If I pick that one up there. So that I'll come over and I'll demonstrate the difference.
So it's a hydraulic manifold. So a manifold, Tim's going to pick up the block of steel now.
Tim's going to try and pick up the block of steel.
Yeah.
That's what it replaces. And I'm not joking. This thing is heavy.
It's 16 kilos. 16 kilos plus all the fittings that screw onto it. And that gets replaced with 1.4 kilos. Same functionality. In fact, better functionality, because everything flows better. So imagine that on an airplane or on a bus or even on your car. And these are, all it does is it just takes fluid from one place to lots of other places. It's a really boring engineering component. But every bit of machinery has a bunch of these on it. Your car has a bunch of these. So imagine that lightweighting, what it does to the aeronautics industry, the fly-to-buy, how much fuel they save a year by having lighter components. And it's why the aeronautics industry are probably at the forefront. They're pushing the limits of this technology the most, because they benefit directly from making products that are lighter.
Yeah. Oh, well, lighter and more ergonomics in space, being able to, really nice if we just curve that around, but it's really hard to do that with a drill into a billet like that.
The block has got holes drilled from every direction. It's not because it's the best direction, it's because that's the easiest to drill from.
Yeah.
Here, the fluid comes in the bottom, out the top, which means it takes less space.
And you minimize drag through
Absolutely.
it.
Yeah, your channels are nice and curved instead of having 90-degree corners to go around. And in fact, the cost to mill, to CNC machine one block, and the cost to print one is the same.
Is it?
Yeah.
Wow. And that's going to come down in price over time,
absolutely.
Definitely.
Whereas if you were going to print the block, you'd have a heart attack. It's probably about $20,000 to print. It's a dumb part to print. So you wouldn't do it.
Yeah. And that's right. I imagine once the metallic powders become more affordable for 3D printing, then the amount of waste that you get in that, well, not waste, but extra material that you've got to buy in that billet and that block that you don't really want. Actually, you don't want, but you have to have. It's going to make this far more attractive.
If you think sustainability, so the metal printers all work with powder-based material. So all the powder that doesn't get melted, you reuse.
Yeah.
So the only waste is what they call support material, which is sacrificial material. So for those of you who run, the cheap desktop 3D printers, they have the hot glue gun based ones, support materials there to support overhanging bits.
Yes.
Metal is for a different reason, but with good design. So this particular part is designed with no support material.
Yeah. And this, I imagine, too, is where you could use AI, where you start to say, here's my rough design, and then the AI says, okay, I'll just tweak this. Is this okay? And we don't need support materials if we do it this way.
Right,
sure. Yeah, let's do that.
Yeah, and one of the big challenges for our lab is we have companies coming to us and they haven't thought about all the post-processing, the work you've got to do afterwards. So we try to teach them how to design the right way for the technology.
Yeah.
It's bringing the cost down. So removing human labor is expensive. So if you're going to have a poor person removing support material by hand, that is really expensive.
Yeah, of course. The two coloured blocks there.
So this is, it's called a gyroid. It's a mathematical construct. So this is, so if you imagine the red side is the hot side, the blue side is the cold side, this is a heat exchanger. So it's like a radiator in your car. So the idea is that the water goes through the red side, the air goes through the blue side.
And it's extremely efficient, I imagine.
Absolutely. And in fact, I've got one right here. Let me pull one out here.
That is so cool.
So I've got all the bits in the box. So this is a liquid to liquid heat exchange. So the hot goes diagonally across and the cold goes through there. And what's on the inside of that?
That's so light.
Oh, absolutely. And it's 1/3 of the size of a conventional plate and tube heat exchanger. So if you look at that, this is the color printed one. That's what's on the inside of it. So it's the red and the blue side separating the hot and the cold side. Hugely efficient and self-supporting. So those gyroids you can print with no support, which is the other thing that makes them really, really nice. So big area for this is, so in fact, that one's for our Formula Student race car team to cool they've got electric motors with cooling jackets around them, and we use those to cool the water on them. Yeah.
Oh, that's awesome.
I did a test, a not very politically correct test on LinkedIn where one of my colleagues is pouring boiling water in the one side and I put my hand on the other and it comes out at sort of shower temperature. That's how efficient it is.
Yeah. Oh, mate, that's amazing stuff. That's just phenomenal. The design on this one, this piece, like it's making my head pop. It's just such an organic design.
Yeah.
It looks like the aorta coming in here.
It does look like, in fact, we had a student design one that looked like a heart. We did it as a student design exercise.
And the way it just then diffuses through all those little channels side by side, I can see why it's so efficient.
Absolutely. And the cool thing here is we've developed the software where we can just import your CAD where you've got your inlets and outlets, and in 30 seconds it'll spit you out one of those ready to print. So again, it's that design process to try to make that as easy as possible for the user.
The performance improvements in industry is going to be amazing.
Absolutely.
But like you say, your guys at the university are going to use that in their car. But imagine if someone's got a dirt bike and they can just print one of those as their fuel filter or something, whatever it might be. It's just, wow, I've just gained 5%. I got 2 horse extra out of that. Yeah.
And that's huge. Anything that makes it lighter, perform better. And again, bad example, but using mountain bikes again as an example, people who ride mountain bikes spend stupid money on their bikes.
Yeah.
So whether it costs $50 more or less, if it's going to reduce the weight and improve their performance, they'll jump on it.
But just aesthetically, can you imagine how desirable those first mountain bikes that come out with those hollow-bodied frames that just look organic? People are like, I want that bike.
Yep.
Yeah.
I've got one of my colleagues at work now. He's redesigning the back. It's a sentimental value bicycle of a friend of his where the back part of the forks broke off. Oh, yeah. And he's repairing it, but he's repairing it with a printed section that'll have all that organic, funky looking stuff in it.
Yeah, that's awesome. That's just so good. What's the little baby hand?
It was actually another prosthetic. It was a 2.5-year-old girl. I did this in Sweden a few years ago. So it was a 2.5-year-old girl missing the bottom half of her right hand. So we scanned the residual limb and then printed the socket to fit that perfectly. So again, it's for extra comfort.
Wow.
And in fact, the real one was just a socket on the arm, and you could plug a bionic hand onto that. But when she was running around the home, her parents didn't want her running around with a $20,000 bionic hand. So this was the passive prosthetic that you could wear for. Now, look, She was 2.5 years old, so we don't know for sure, but she was showing this off to her friends, saying, look how cool this is, sort of thing. So, and again, you can imagine having, your kittens on it or customized the way you want it.
Of course.
And again, it weighs next to nothing, so that ability to make things lighter. But the big one here is that socket on the inside.
Being fitted perfectly. Yeah. It's such a positive, enabling technology.
Absolutely. And to me, a lot of this, what's missing now is that software to make it easier to use. And that's where the AI side comes into it. That'll hopefully make that a lot easier and a lot more automated.
Well, you're saying there is already some AI to 3D technology starting.
It's starting there. So already, I think it's Google, where from a 2D picture of you, which is weird, they generate a 3D model. So they interpolate the other pictures and then use photogrammetry to build it into a 3D model. I think it's DALI, or one of the text to right now 2D images is working on text to 3D. Still fairly rudimentary right now, but as I said, it's a year or 2 or 3, and they will be there.
That's amazing. It's the other thing which is blowing my mind is I think it'll be in a year's time. It'll be text to your own video, your own movie.
Yeah.
And they'll be really good. And it'll be Friday. Hey, want to come around and watch my latest film? You're like, what's it about? I give a brief synopsis. You seriously made a film about that? Yeah, come check it out. It's awesome.
And you think, what does that mean for the film
industry?
What does it mean for Hollywood? For
disruptive technology. Like now that I've held some of these and seen some of these things, disruptive technology. Yeah.
And what you really wonder about is, I was saying earlier, right now it doesn't replace knowledge. But, will the AI be able to get emotion into the film? And that's what we don't know. But, because I think that's what will make the difference between the AI-generated film might be a bit dry or mechanical, whereas the Hollywood-generated film will have the emotion in it.
I think,
or will it?
I think that it will. The reason I say that is because when I look at some of like DALI and some of the other text-to-image ones, you can say, do it in an impressionist style or do it in a surreal style. And so you can kind of give it a genre or a feel to go with.
Steven Spielberg style.
Yeah, that would be something like that. Or give the film a very dark and menacing feel. And it will start to capture that. I think so. I think that will come. I don't think AI is going to be something where we will see, it can think of amazing things we can't think of. The reason is that it's based on a set of data which we humans have given it. And as I understand it, it's roughly trying to model how we think our brain works anyhow in its neural network. So it's not some new created ability or way to think. So.
That's right. I mean, to me, I guess that's what's important, is using it for the right reasons and in the right way. And as long as we do that, I think it's going to be a huge benefit to what we do. It's going to, in this area particularly, it's going to make a big difference.
Yeah. I was talking to a friend who works for a major software company, and he said, I've been so busy with all this ChatGPT stuff. And I said, are you using it at work? And he's like, oh, yeah, we're using it. And he's like, but we're using that, we're using DALI, we're using this and something else. Like they're really adopting it into what they do with their software. Yeah.
That's great. And for writing code, if you write code, ChatGPT will generate 80% of the code, and you're going to have to tweak it and massage it to get it right. But,
some of the guys I work with, we were playing with ChatGPT a couple of weeks ago, and I sent out an example, and one of the coders in my team was like, well, at least I can't code. And I went, write me out something JavaScript to make a field variable, blah, 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 blah. And it spat it out, and I sent it to him. He was like, oh, wow. And then I said, oh, hang on. I got the code it gave me. I broke it, took a bracket out, and said, hey, fix this. And just fixes it straight away. Yeah. Well, yesterday I read on Twitter that ChatGPT has passed a Google software engineer exam.
That's right,
at the 183 USK pay grade. Like it's one of the higher jobs. Passed. Fuck it, just hire ChatGPT.
And I think about when I code, my biggest problem is I miss a semicolon. And it takes hours to find it. I have ChatGPT be able to pick it up instantly.
There's someone on Twitter that I follow, and they just show examples of, like, here's the code I wrote to do something, which I thought was really good. Here's ChatGPT's refined version. It's like, wow, it's a third of the code. Yeah. It's amazing, disruptive stuff.
It's a fun space to be, you got no choice. You have to keep abreast of it. You got to know what's going on because it's going to affect all of us for sure. This
is such a good array of examples of things that you can do with 3D printing, which has pushed my understanding and thinking of it. Because for me, I've often just been limited by, I've got a broken vacuum, it can apart. Do I really want to buy a 3D printer just to do that? But then when you start to see these type of things, it's mind-blowing. It really is. It's just amazing.
Absolutely. And to me, what's exciting is people, and this is, Joe blogs, people finding new applications for it, saying, what if I did this for it?
Yeah. I'm really interested to see what happens in the next couple of years here, just how rapidly it does progress. Has there been any work done with printing like small scale animals and things?
So nano printing, I mean, it's happening, printing at that very, very small scale. Mostly now it's sort of printing little lab on a chip type applications where you can get the cell. So it's printing microfluidics, so little channels where the cells line up in a single line so you can count them, for example.
Yes.
But on the nano printing side, there's a lot of work going on in that area. So printing at a very, very small scale. Practically, I've seen it used for surgical tools, for one-time use surgical tools where the doctor needs a pair of grippers to go in and grab something at a tiny, tiny, tiny scale. Another really cool one that you can Google later is Technical University of Vienna printed a castle on top of a pencil. So if you imagine the tip of a pencil, you see nothing, but then you zoom in and you zoom in again and you zoom in until you get to that nanoscale and you see a full castle printed on top of the pencil. So at that small scale, it's already being done today.
These things really are, I think, for a lot of people, it's just amazing. It's not magic, but it's touching on it.
It's getting there. And you got the two ends of the scale, the extreme big size where you're printing houses, and then the other end. So I know people at the University of Southern California, they're working on printing little nanobots, so little robots that swim around your bloodstream to keep you healthy. Now, we're still a while away from that, but
they're working on it and prototyping it.
It's going to happen.
What do you think of the 3D printing of houses?
I mean, it's huge all over the world now. I mean, everywhere. Even in New Zealand, there's one being printed right now in West Auckland, I think. So a company called Corox, who brought in a 3D printer for printing concrete, and they're doing the first architecturally designed 3D printed house in New Zealand right now. Mostly around the world, a huge amount of them, but they've been really boring. They've been cube houses that you think, well, you could precast them way more effectively. So I think what we need is the architects to get involved to say, I can do something different with this.
And is that what you're saying? This one that's being printed in West Auckland is an architecturally designed one?
House, It'd be interesting to see what it looks like when it's finished. But it's, in fact, in Amsterdam, there's a printed bridge, printed out of metal, in fact, a bridge that crosses one of the canals. And that is an amazing work of art. It's all these organic shapes you were talking about. These, it looks like it could come out of Game of Thrones or something like that. But it's a printed bridge.
So the houses that are being printed, what are they? Are they using mud or is it cement?
Mostly concrete.
Concrete.
It's concrete. It's a special mix of concrete with fibers added to it and so on. But there is a company printing out of mud. Sort of printing, out of.
And again, with those, I imagine now that they're just doing just squirt printing and letting it set. But then in time, I could see how you would get to parts of a house. You go, okay, well, this is where we want to run in the communication cabling and the power cabling and the water piping and that sort of thing. So for this block here, maybe it's prefab, but if not, it might be, okay, we'll print the gaps here in the most efficient way or how the Sparky wants them, and off we go to the next part.
Yeah, and look, I mean, as I said, all around the world, it's a huge area of growth. There's just been a big report on printing in construction, the construction industry. Military is huge on it. NASA, they're planning the mission to Mars. And the idea is when they get to Mars is instead of sending a rocket full of bricks up, you harvest material from Mars, print out habitats.
Print some shelter. Yeah, you've got to do something like that. That's a really sensible idea when you think about it. Have you seen I think they're called Spin Launch, the company Spin Launch. So instead of building a rocket and having all this fuel, which you've got to push up to get a tiny payload up, these guys have built this spherical unit, and in the middle of it, there's a pin with an arm coming out, and attached to the end of it, 90 degrees perpendicular to it, is what looks like a little missile. And this spins and gets up to 10,000 RPM.
Very cool.
And then it's got a little opening here and releases, and so it's just got this insane velocity when it's released. So it has a tiny amount of fuel to get it further.
Very cool.
Spin launch. Space tech. I'm trying to get a guy on to come and talk about some space tech. He works in that field because I think it's very interesting as well.
Very cool,
yeah, and lots of use for this there.
Oh, for sure, and because again, it's lightweighting, it's on demand. NASA had a printer on they've got a printer on the space station, plastic printer, just a straight low, extrusion-based printer for printing replacement parts on the space station in plastic. Apparently, one of the things the astronauts wanted the most, strangely enough, was a back scratcher.
Imagine.
these uniforms and they can't reach. So that's
Fair
where
enough.
the number one priority item to print was
a back scratcher.
Yeah.
That's interesting. Isn't it? The real need for this thing in space is for a back scratcher. You think it's replacement parts, but no. That's really good. What do you sort of think then for the future? Where are you interested, or what are you working on or looking at doing with this?
So, two of the areas we're working on. One of them is food printing. So printing food that's custom made for you, the user. So there's a lot of food printing happening around the world. Mostly it's sort of paste in a tube and you're extruding it out, you're squeezing it out and reconstituting the food. We're working with powder-based protein. So we spread powder-based protein, and then we've got an inkjet printer that prints the glue, so an edible glue, but then the other printers could be doing extra vitamin for you, extra calcium for the next person, the flavors and all that. The idea is food for the elderly, people with dysphagia who can't chew or swallow. They have something that looks like a carrot. It's crunchy. They bite into it. It instantly falls apart, and they can swallow it.
I was thinking for hospitals, it would be the perfect thing. These people in hospital just print them what they need. All their vitamins goes in there.
And they've got specific nutritional needs they need. So that's one of the areas we're doing a lot of work in. In fact, just recently we printed a little Pikachu character, and the different colors on it were the different ingredients. The calcium.
Wow.
And the other areas, again, in the housing industry. So we've got a project now where we call it nodal printing, where we print little nodes. So as I said earlier, when you get to big size printing, it gets really expensive. So the idea is, can we print just nodes and then join them together with beams, tubes or I-beams or 2x4s or what have you. So you're only printing tiny little bits. And the idea is to build a house out of these. The idea is you go to Bunnings, you buy the house kit, put it on your trailer, truck to your site. All the nodes are numbered, so you know what order to assemble them in, and you build up your house without needing expert builders, without needing plumbers, without needing,
And you insert the pipe into the hole in node 27, and the other one is at the right angle to hold the next member.
Everything's at the right angle. So it's almost like an IKEA to build a house. Now, we're still a long way from there, but it's one of the fun projects we're working on, and it's trying to maximize, because every node will be different. It's, again, perfect for 3D printing, and we can automatically number them to generate the assembly plan.
That's a fun idea. Yeah. That's kind of got that Lego feel about it.
Absolutely. It is Lego or Connect or Connect or whatever the game is. Very similar to that. And in the lab, we've got a big sort of Venus de Milo statue that we've done that way with, I think, 100 or 300 nodes. And we assemble it, and it looks like the Venus de Milo.
Wow. That's cool. That's cool. Yeah. Are you getting a lot of interest? Like, are you getting lots of students wanting to come in and join your classes?
It's a hot topic now. You mentioned 3D printing, and people say, pick me. It's a hot topic, and all the companies know about it, and they're now wanting to know, how can we use it to add value to what we're doing? So because of that, they're looking for students that have got a bit of experience in that.
People like a rocket launch in New Zealand, I guess they must be using that sort of technology. Rocket Lab, sorry.
All these space companies are using it. Boeing, Airbus as well. That's not in New Zealand, but New Zealand Rocket Lab. Though a lot of their manufacturing happens overseas. Rodin Cars in Christchurch, who do race cars, they've got probably the biggest metal 3D printers in New Zealand right now.
Wow.
To print their gearbox and a lot of the engine parts out of titanium.
And so when you print something, like this piece here that's been printed, that was aluminium, that one, wasn't it? So what are their mechanical properties like? Are they strong?
Straight off the machine, they're typically better than cast.
They're better?
Better than cast, yeah.
Wow.
It's a casting with no imperfections. So when you cast metal, you get voids, you get slag, you get all sorts of crap getting into the part that could weaken it. Here you get a perfect casting. And then with heat treatment, you can actually get up to forged or wrought strength. So, you can get full strength parts. And that's why for the aerospace industry, you've got to know that if it's vibrating at a high rate, it's not going to crack. And there's different post-processing operations you can do to get it to that level.
Wow.
Straight off the printer, you're 99.5% dense in terms of the density of the part. When you're casting 96, 98% density, you are a happy camper.
Yeah.
So
and you're 98.
Yeah. 99.5 straight off the machine. And then some people are tweaking the parameters to get up to 99.9% dense parts.
And I'm imagining you could start to do things like, when you're printing, you generate a magnetic field around what you're doing to sort of, if it's a ferrous material, to align things to get certain properties, maybe make the material magnetic if you wanted to then. And
some of the guys at AUT, they're working on duplex stainless. So it's stainless steel, but they're able to control the magnetic properties of, within the parts. So certain areas are magnetic, others are not magnetic. And It's so cool. We don't know what we're going to do with it yet, but we want it because it's
that's
cool.
bonkers technology. That is so good.
Some colleagues in Sweden, they wrote their logo in the microstructure of the part. So you can't see it until you go with a microscope, polish it, and you can see the logo. So, but you think about it again for cyber or security of making sure the part is a genuine part.
Well, that's what's like they used to do with, what was it, Subarus with the chassis. They used to spray those little micro dots, plastic little transmitters, whatever they were. But now it's just baked into the grain of the material there.
Yeah. Or even, showing the wear of a part. So you get a part that as it wears down, it changes color.
To tell you how,
it goes from green to yellow to red, and red means time to change the part. Being able to do that sort of stuff will be
there's
quite
just
amazing.
so much of this, I'm sure we just haven't even thought of yet because we're not used to the technology, haven't had the opportunity to figure out how we could use it. Yeah. Oh wow, Olaf, thank you so much. This has been the most interesting talk. It's just phenomenal stuff.
Absolute pleasure talking to you. It's been great.
One last thing. So. Do you play your instruments?
Yeah, I do. I don't have enough time anymore to play a lot, but mostly I'm a bass player, but I've picked up a little bit of guitar over the years. But yeah, every year my New Year's resolution is to get back into a band, but never quite find the time to do it because so many other things going on.
And so you've shown the guitars, but what else have you made instruments?
Drums, I've done about 4 or 5 drum kits. I've done keyboards. Well, the keyboards are just a Yamaha digital piano, but with a new case around it. Mm-hmm. So basses, guitars. I've done a saxophone, which didn't quite work. It was leaking air, and on a sax, if you leak air, I managed to get 7 or 8 notes out of it, but I need to do a redesign of that.
But did that have like the little pads? Did you put pads on it?
I put pads on it.
Oh, you did.
But where I went wrong was the springs. So the springs on a saxophone, they're basically just steel spring rods hammered into the metal, then bent. When I did the same thing in plastic, they just twirled around and didn't give it. So I had rubber bands wrapped around it. So I'll do another design iteration of that to get that working properly.
Yeah. And have you made yourself a bass?
Yeah, I've done several basses. I've got a Beatles-themed bass guitar with, iconic scenes from the Beatles around it. I've got 2 or 3 bass guitars that I've made for myself.
Oh, nice. Awesome. Hey, thank you very much. Cool.
Absolute pleasure, Tim. Thank you.
Oh, I don't think I stopped smiling the whole time.